Hello and welcome again to Cotton Innovations Limited. It's great to be talking to you about our processes that we use and tools that we use, and we're going to introduce you to the whole idea of stability in a process. What do we mean by stability in a process? How often does that process fluctuate, and what does it fluctuate, and how it moves about in terms of its influences from other things. So there's a whole bunch of other tools and techniques that you need to think about. You may need to go and look at the videos on fishbone analysis, which will be really powerful. That will help you understand this. CNX mapping will really help to help you. Data collection would be able to help you on this. And why do we need to understand stability? Stability, we often talk about how capable is a process. So you may want to look at the video on capability analysis. But when we're looking at stability, what we're saying is how stable, how much does it fluctuate? And it's something that we don't often report on, but we often ignore. Now, if you're doing capability analysis, and as we mentioned in the previous videos about capability analysis, we use a term called CP and CPK. You can't quote that without having done this data first, and we'll show you where that comes from. So you have to do this before you do capability. So in our series, we're looking at capability analysis here in the FMEA. So what I'm going to do, this graph here is a time series plot. What do we mean by a time series plot? Every data point is following the previous data point and is time related. Now that's really important. So if your data is sorted, manipulated, changed in any way, you really should not be using this graph. The data should be coming from a time order dependency, because you're going to be making judgments about the stability of that process over a period of time. By sorting it or changing the list order or doing anything to that data, you're affecting what you're going to interpret that data as. So on the first one here, the individual graph, this is a moving range. So we're going to plot our data points. We'll join those data points together so we can see how they're moving. Now, when I get my data points, what I'm then able to do is I'm able to calculate something called the mean. The mean, or the average as we call it, of my data. So I can see how the data points are oscillating either side of this central value. Now bear in mind, the mean is a really useful number, but it's also a meaningless number because it doesn't exist. I then have got these two upper and lower boundaries. Now this upper boundary here is plus 3 standard deviations, and the lower boundary is minus 3 standard deviations. So have a look at our video on standard deviation, how to calculate standard deviation, what it is. But effectively, this is telling me that between this point here and this point here, 99.73% of all of my data should fit within that group there. Now there's a whole series of boundaries and rules that go with my data, so reach out to us at Cotton Innovations Limited if you'd like to know more about SPC and use SPC, because it's quite a complicated subject, but it's actually quite simple once you've got your head around what's going on. So this then tells me if I've got issues in my data as to how my data is being distributed within these ranges. But then I have this graph at the bottom here, which is called the moving range graph. Now that's a really, really powerful graph, because what I'm going to do here, these are the actual values. What I'm going to do is I'm going to take this point here and this point here and subtract them from each other. And that's going to give me a range of how far that moved. And then I'm going to subtract this value from this value. And that's going to give me, again, another value of range. And then I'm going to subtract this value from this value, and that'll give me another value of range. And then I'll subtract this one from this one, and that'll give me another value of range. And then I'll subtract this value from this value, and that will give me another value of range. And then I shall do this one from this one. 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 This one from this one, and this one from this one. So what I'm now able to do is I'm starting to create a picture of how my data is moving, how the range of my data is moving over time. This again gives me two red lines. This would always be 0, because you can never have a negative value in a moving range, because we're talking about absolute difference, not actual distance. And also I will have +3 standard deviations based around the moving range. And the green line will be called the moving range average. Or the moving range average. Now this is a really important value, and this is why we want to know if my data has been sorted, because this number here is what is going to be used to calculate my CP. Now in the modules on CP, CPK and PP, PPK, we talk about the two calculations. This is a really important number because it links into our CP value. So if this is a normally distributed data points, and I'm seeing a nice even distribution of those data points, what I'll find is that this average, when I divide it by the Shewhart constant, will calculate a similar value to the standard deviation. If, however, I have patterns in my data, this number will not calculate properly, and what I shall see is a difference between the two, which starts to indicate I have a problem within my process. So that gives you an introduction into stability of my process. We can also look at things like outliers in my data. An outlier would be something where this data point did not occur here, but it occurred up here, outside of the upper boundary. So now this is beyond 3 standard deviations. This would be flagged up by SPC to say I have a problem. I can have a look at the 8 rules that drive my process. So you want to know more about more about SPC, reach out to us at Cotton Innovations Limited. We would love to help you with our processes, and we'd love to be able to show you how to use this as a really powerful tool, both within your FMEA and also within general process information control, so that you're able to maintain the stability of a process. You can do this for mechanical processes, you can do this for attribute processes, office-based processes. It's not only a mechanical tool. Hope you found this useful. Thank you very much for listening, and we look forward to you reaching out to us, and we would like to help you with your data collection. Take care now, and speak to you soon. Goodbye now.